In Chapter 5, Problem 87 and Problem 88 will be covered next page, are about using the relationship of the effusion or diffusion speed of the gas with their molecular weight. Generally speaking, the heavier the molecule is, or the higher molecular weight they have the lower effusion speed. So if we have gas 1 and gas 2, if their effusion speed R1 over R2 is actually equal to square root of the molecular weight of 2 over molecular weight of 1. So R is the effusion speed. In this problem, R could be estimated as, or let's see, not equal to, R could be estimated as that more number of the gas divided by the divided more number of the gas by the time of diffusions. So in this problem, a gas evolved from the fermentation of glucose is found to effuse through a porous barrier in 15 minutes. This is the time, 15 minutes, under the same condition of the temperature and pressure. It takes an equal volume of nitrogen gas, 12.0 minutes, to effuse through the same barrier. It's the same. Everything the same, but the effusion time is different. 15 minutes for unknown gas, 12 minutes for nitrogen. Calculate the molar mass of the gas and suggest what the gas might be. So apparently we need to use these equations, but remember that we have the effusion time, not the speed. But here we can estimate that effusion time is about, we divide the more number of the gas by the effusion time. So therefore, the longer the time it takes, the lower the speed is. So it takes longer time for this unknown gas to effuse 15 minutes than the nitrogen, which is 12 minutes. So which one effuses faster? Nitrogen. So which one is lighter? Nitrogen. So therefore nitrogen, molecular weight of nitrogen gas is lower than this unknown gas. Okay, now we can try to solve these problems. So starting with our equation, gas 1 and gas 2, and we have unknown gas and gas nitrogen. So if we see, we call unknown gas, and we say the effusion speed of unknown gas RU over effusion speed of N2. Okay, so we know it takes shorter time for N2 to effuse, therefore the effusion speed of the nitrogen is faster than the effusion speed of unknown gas. So therefore the effusion speed Rn2 is higher than effusion speed of this unknown. And if we use this, okay, we estimate the effusion speed by divide the more number of the unknown gas, more number of the molecule by its effusion time. So in here, for unknown gas and nitrogen, they have the same condition of temperature, pressure, and volume. So when the ideal gas has the same temperature, pressure, and volume, that means they have equal number of mole. So therefore, in this setup, the more number of unknown gas equal to the more number of nitrogen. So now we'll see the estimate of the effusion speed of unknown gas will be more number of unknown gas, which is equal to nitrogen, we use N, divided by the effusion time, which is 15.0 minutes. And the effusion speed for nitrogen will be the more number of nitrogen with the same more number of unknown gas by the effusion time of nitrogen, 12.0 minutes. This gives us, cancel. This gives us 12.0 over 15.0 equal to 0.80 and 3 stick figures. Okay. Then we also know that RU over Rn, effusion speed, equal to m molecular weight of nitrogen over molecular weight of unknown. Now we combine this equation here with this equation. What we got? We got that molar weight of nitrogen over molecular weight of unknown, square root of that, equal to 0.800. And molecular weight of unknown equal to molecular weight of nitrogen over 0.800 squared give us 28.01 gram per mole. This is the molar weight of nitrogen over 0.640. It gives us 43.8 gram per mole. This is the estimate molar weight of unknown gas. It turned out is probably carbon dioxide. Okay, now with this knowledge, let's move on to the problem 87. In 87, that we know that nickel formed the gaseous compound of the formula nickel with carbon monoxide, CO, with X, and we don't know the X. What is the volume of X given the fact that under the same condition of temperature and pressure, methane, CH4, effuses 3.3 times faster than the compound? So in this setup, we know we have two gas, nickel with this carbon, X number of this carbon monoxide, and methane. We know the effusion speed. That effusion speed of methane over effusion speed of this unknown compound. Okay, methane effuses 3.3 times faster than nickel compound. So therefore, the effusion speed of methane over effusion speed of this unknown compound is 3.3. And also from the previous slides, we know that effusion speed of methane over effusion speed of carbon monoxide equal to molar weight of nickel carbon monoxide, X of that, and molecular weight of methane. Now we combine equation 1 and equation 2. This part are the same. We got molar weight nickel with XCO, molar weight of methane equal to 3.3. Then this leads us to molecular weight of nickel bound with CO equal to molecular weight of methane times 3.3 squared. And we also know that the molecular weight of this compound can can be calculated based on the atomic weight of nickel and atomic weight of CO, which give us 58.69 gram per mole. That is for nickel, and 28.01 gram per mole. That is for CO times X, equal to 16.04 gram per mole times 3.3 square. We solve this equation for X. For X, we have X equal to 4. Okay. Therefore, the compound is nickel with 4 units of CO.